is up, YouTube? Woo! Mr. Keen coming at you live from the studio. I'm at the house with the dogs. Today, we're going to be learning about the different types of forces. Okay? Force number one, we all know it. Gravity. Okay? The classic example is an apple falling. Gravity is the force that pulls everything straight down. Okay? Technically, it's pulling everything towards the center of the earth, because the gravity comes from Earth's large mass. So it's pulling everything towards the center. Okay? We all know that one. This one is going to be new, though. This one I didn't learn about until college. It's called normal force. Normal force basically pushes upwards on objects. Or a better way to think about it is perpendicular to the surface that it's on. So if you have this laptop or a laptop on a table, the table is pushing up on the laptop. Okay? The idea is that normal force balances out gravity. So if you didn't have normal force, you'd fall straight down to the center of the earth. That's why normal force is important. And if something's slanted, like on a ramp, the normal force will just go diagonal up, perpendicular to the ramp. So the normal force basically just pushing upward on things. If you're on the ground, it's pushing up on you. If you're on a ramp, it's still pushing up, but up at a diagonal length. Okay? So that's normal force. The idea is that it pushes up on things. And that's how scales work. If you're on a scale, your scale's measuring how much they have to push up on you. Okay? Sneak peek. Later today, we're going to do body diagrams. The simplest one, let's say you have cheese on a piece of table. Okay? So the force is acting on this cheese. The cheese is getting pushed down by gravity or its weight. Physicists use weight to represent mass times gravity. So the weight of the cheese is going down, but the table is pushing the cheese back up, so the cheese doesn't fall. And if these forces, these arrows are equal, the forces are equal, so the cheese is not moving. Okay? Now, one of my favorite shows growing up was Batman Beyond. One of the villains does not have normal force. He is able to move without normal force. Okay, you're going to see what happens. So, he's a villain in Batman Beyond, and he's losing control of his powers. So watch what happens when he doesn't have normal force. He basically just starts sinking through the ground. But that's not all. The only force that's still affecting him is gravity. So he's going to go through all those walls, but watch what happens. Okay? Batman is going to do the right thing and try and save him, but it's going to be very difficult. So here Terry is. He's trying to save him from falling, but he keeps going. He doesn't have any normal force. Nothing is pushing back up on him. So he's just going to continue to fall. I know it's a little traumatic. It's a very dark show, but it's also one of my favorites. Okay, now he's at the bottom floor. And he's going to keep falling and falling down until he hits the center of the earth. Yep. So that's why normal force is important. It pushes back up on things. The next force is called friction. Friction is a force that slows things down. Okay, so if you kick a soccer ball, friction from the grass is going to slow it the other way. It also works in the air too from air resistance. So friction will slow down the soccer ball. And friction always acts in the direction opposite from the way you're moving. Okay? So if the soccer ball's kicked that way, friction's going to go the opposite way. Okay? I have another clip of SpongeBob going down a rope. I want you to think, what direction is friction happening in this clip? Okay? So they're trying to be cool. They're going down the rope, but they're not letting go. So the friction was going upwards while they were going down, and it caused them to get rope burn and burn their hands when they were underwater. Okay. Next one. It even happens on slides. You don't think about it because you go pretty fast, but there's still friction diagonally going up the other way. So as that panda's sliding down, friction's going to go up the slide the other way. Yep, so that's friction. It slows objects in motion down. Here, I want to show you another body diagram, they're called, of a car on a ramp. So here we have the car. We all know that gravity is going to pull it down, but the arrow goes straight down to the center of the earth. It doesn't go down on the ramp, it goes straight down. A lot of people think it goes down on the ramp, but gravity's pulling it straight down. Friction's going the opposite way that it's trying to go, and the normal force is pushing back up from the ramp, but it's going diagonally up. Okay? Now I want you to try. You throw a bowling ball down the lane. Okay? It doesn't have a name for it. You can just say force from the throw going to the right. What forces are acting on the ball? Draw them in a body diagram. Please pause the video now and try and draw a body diagram of the bowling ball while you're throwing it down the lane. Okay? I'll give you a hint. Add 3 arrows and label them. Okay, so remember, everything has gravity, so you should start with that one. Next, if you're throwing the ball to the right, it's going to have friction going to the left, and since the ball is not falling, it has normal force from the lane. So the normal force and the gravity cancel out, and yes, it has friction to the left, but it's not as strong as the force that you throw it with. So that's a body diagram of a bowling ball. The last force I want you to know is called tension. Okay? Tension is a force from pulling, usually from a cable or rope. So like, let's take this wrecking ball. The wrecking ball is held up, the tension's going upwards because the ball is not falling. The cable is holding the ball up, so tension goes up. Okay? And then in this case of tug of war, there's tension going to the left and to the right. Okay? So that's tension. A force from pulling. Just think, if you pull something, that is tension. Okay. Next, I want you to try this one too. You are playing tug of war against your best friend. Draw a body diagram showing all the forces occurring. Note, yes, you are slightly stronger than your friend, and you're the one pulling to the left. Okay? That'll help you answer this one. Please pause the video now and try and do it yourself. Hint, you need 4 arrows, and your overall motion should be to the left. Okay? Hopefully you got that you're not falling, so you have gravity and normal force going up and down, canceling each other out. There is friction from your friend. You could also call it tension because it's a pulling force that's providing friction. And then you're giving tension, so you're pulling to the left. You're pulling to the left, and the arrow's a little bigger because you're stronger. So that's how you do body diagrams. You basically start with the dot, the object, and then you draw arrows to represent the different forces acting on it. My hint, you should always start out with gravity. Gravity will always be there. Okay? Thank you so much, everyone, for staying with me the whole time. I hope you learned something new. I hope you have a great day. Bye.